Okay, so today we're going to go through some basics of MATLAB and image processing in MATLAB. The first what we'll do is kind of orient ourselves with MATLAB, then we will learn a few things about matrices and how to do different things with them. And then we'll talk about how images are represented in matrices, and then go on to play around with a few image functions. So if you haven't installed MATLAB yet, you can do that on the Computing Services website at Carnegie Mellon. It requires a license, and the license is only good if you're on the Carnegie Mellon network. However, there is a program called Cisco AnyConnect, which is also linked onto that website, the website with MATLAB. Or you can just Google Cisco AnyConnect CMU and find it, and it allows you to create a virtual private network, which is basically a program that allows you to connect to the Carnegie Mellon network even though you're not on it. And so when you do that, the license will work. Okay, so I just loaded up MATLAB. There's a few parts of MATLAB here that are useful. And this right here is the command window. So you can type things in here. It's a REPL, so you can just start typing code, and then it will execute it and save the variables which you have up to this point. Over to the right here is your workspace. So if you just notice, this A came in because I created this variable with value 1. So if I was to make another variable called b equal to 2, then it will let me know here that I have a variable called b and the value is 2. Down here is your command history, and then over here are your files, which at the moment we don't have any. So I'm going to switch to a folder where I'm going to be working. Okay, so that's pretty much it for the program. When you want to create new files, you can go over to here and click New File, and there's different options for this. For the first homework, the two you'll need are a script and a function. Okay, so let's start with looking at matrices. So I'm just going to create a matrix here. So you can make a matrix in a single line by writing down the first row with each value separated by commas, and then when you're done that row, you put a semicolon and start the next row. And so that's the matrix that we have. I just chose those numbers because, as you'll see, those kind of represent the indexes. So you can actually, I'm thinking I'm just going to make this m. You can grab a variable or grab a value from the matrix by indexing it. If it's a two-dimensional matrix, then you will need two values to index it, and the first value is the row, and the second value is the column. So if I wanted to get the middle value, then I would get the second row and the second column. So MATLAB uses indexes at 1, not 0, like every other programming language, and so make sure you remember that, because that's something that could be a bug in your code if you're assuming that it starts at 0. However, if you do try and start it at 0, if you actually try and index 0, MATLAB will throw an error and let you know. Okay, so if we got the value at that cell, so that this is the first row, and this is the second row. And so then this is the first column, second column. So we got the value at the second row and second column. So it's right here, and then we got it. You can also index sections of the matrix, not just a single value. And there's a notation with semicolons. So if I wanted to get so what it basically does is allows you to give ranges of indexes instead of just one single index. So if I wanted to do the first box right here, that includes these numbers right here, the top left corner, I guess would be the way to describe it. Then I would grab columns 1 to 2 and rows 1 to 2. These are rows, and then columns 1 to 2. I could have also chosen to just get the first column. I could have chosen to get all rows, in which I just you don't need a beginning and end in the range. It just defaults as the whole range. And then I could get the second row on. Oh, oops, sorry, I have to put an end there. So if you want to go from a number to the end, then you can just put end instead of having to do length of something. Okay, and you can also, doesn't necessarily have to be ranges. You can also just give this thing a vector. So this will choose rows 1 and 3 and columns. Let's do 1 and 3 as well. So if we look back at M, we're getting this, this, and this, because we're taking everything that's in the first and third row as well as the first column and second column. So if you're indexing with vectors, then it's the intersection of the rows that are in here, the values that are in the intersection of the rows in here and the columns in here. Alright, give me a moment to check off the things I just said on my list. Okay, so now that's pretty much explains how to get values from a matrix. And now we're going to look at setting values in a matrix. And the way you do this is you still index it with the same way. So if I wanted to, let's make a temporary matrix. So right now it's the same, but let's set the top left value as 0. And so we would index the top left value with 1, 1. And then we can set it to a value. Let's make it 0. And so now we have a matrix with 0 in that value. As with getting items from a matrix, you can also use a vector. So we could have taken the first and second row and the first column, the intersection of those two, and set them to 0. And so forth. So that's how you set it to a value. You can also set whole sections of matrices to different sections, or to different matrices. So, for example, this will take the. Oh well, let's do this. Sorry. Let's set it back to what it was. Alright, so let's say we wanted to take the whole first row and set it to a new set of variables. So we have the whole first row, and we'll take, the whole first row, that would be the right way to index that, and we're going to set it to a vector. And so that allows you to take a whole vector and kind of just plop it into the matrix. You can do the same thing with full matrices. So if we were to get the bottom left matrices, or bottom left section of the matrix, that's the bottom left 2 by 2 section of the matrix, and set it to some random sequence of numbers. That's how that would work. Okay, you can also search in a matrix. Well, actually, I think I should first explain vectorizing a matrix. Or making a whole matrix a vector. Okay. So if you take a matrix and just give it a semicolon in the index, then it will basically flatten the whole matrix into a one-dimensional vector. So yeah, this was the original matrix, and that's the flattened matrix. And so the reason that's relevant is that you can use this find function to find where in the matrix different things are. So let's say we're going to find where in the matrix is the value 22. So the answer is 5. And so 5 doesn't really make sense when you're looking at this, because what does 5 mean here? But what happens is they kind of, as you can see here, when it's vectorized, they go from they go row by row. So they'll start at the first row and then go across. Or sorry, not row, column. So they start at the first column and go down, and then the next one, and then the next one. And so the fifth one would be the fifth one in that manner. So we have 1, 2, 3, 4, 5. And hopefully my cursor will show up on YouTube, because this thing's pretty thin. Okay, so you can use all different types of logical operators here. So if we were to get all of the ones that are below 22, then it'll give us all of the indices of those. And so you can, when you index a matrix, you can use those. If you're indexing a matrix, a two-dimensional matrix, or any dimensional matrix with a single vector, it will index in that manner. So although this matrix is a two-dimensional matrix, if we were to get the first and fifth element, we can do it that way. So the reason this is helpful is that you can very quickly set things. You can search for things in the matrix and set those cells to a certain value. So if I was to find all of the values that are under 22 and set them to 0, that's how that would work. You can actually just shorthand it like this. Oops. Yeah. So that's that. That's how you can find stuff in a matrix. Another thing you can do is you can do math on a whole matrix at one time in one operation. So, let me get this to the original thing. Okay, so if we wanted to subtract 10 from all of these values, then we could just do m minus 10, and it'll do it for us. Or if we wanted to divide by 2, You can do that. Yeah, so you can basically take every mathematical operation and do that. Okay, so now that's pretty much it with matrices. And now we'll move on to image processing. So if you ever need to do something with an image and you're not sure how to do it, it's really easy to find how to do something on Google because so many people have used MATLAB and asked questions, and other people on the internet have answered them for them. So sometimes I will intentionally just Google something so that it's I can show you guys how easy it is to find things that aren't so simple. So one thing that is really helpful is the help function. So if you want to find out what a function does, or find out the documentation on it, you can type help and then the function name. So there's a function called image_load, or no, it's imread, IMREAD. And if we wanted to know how to use it, we would type help imread. And so what this comes up with is a documentation on the function. Now, it's kind of not really that nice to read in here. They do format it pretty well. But you can always get the same exact information from the MATLAB website. So if I was to Google how to open an image in MATLAB, the first thing that's going to come up is this. And all of this information right here is actually the same exact information that is right here. It's just in what I would consider an easier format to read. So the two main parts of any documentation are the syntax and the description. So there's normally different ways to use the function depending on the parameters you want to use, and also what you're outputting. So if we look here, imread is a function which takes a file name as the first argument, which is a string that is the file that you want to open, and then a format string which is the format of the image. So sometimes if there is a parameter here that is in italics, then they'll describe down here what the possible values of the parameter will be. And so this here explains all the different formats you can use. So in the homework example, we're using a JPEG image, and so the format will just be JPEG. So let's do that. Let's open up that image. So if you see, I have this flower.jpg in the folder that I'm currently in, so MATLAB will be able to find it. If it's not in a folder that you're currently using, then you'll have to give either a relative or absolute path to the file. Okay, so now we have this image, which is the flower JPEG, in a variable called f. And so there's a few things you can do, few helpful things. If you wanted to look at the size of the image, it says that it is 300 by 400 by 3, and so this means that it's 300 by 400 pixels, and then there's 3 color channels. You can also look at the class of it. This means that it's unsigned integer of 8 bytes, which means it has values 0 to 255. So every single pixel is composed of 3 values, a red, green, and a blue value. and each of those values is a number from 0 to 255. So for each pixel you have associated with it a triple of values with each value from 0 to 255. Okay, so let's look at the next function that we'll go over, which is to resize an image. So I wonder what the function for MATLAB resizing is. There it is. It's called imresize. So what this function takes as parameters is the image A, and then a scale, which is how much you want to scale the image by. And if you notice here, one of the possible ways to call this function is with a method parameter, and as it's in the italics, that means that it's from a set of predefined strings that are defined here. And so there's different methods which you can use to resize, and here we have the bicubic method, which is one of the better ones. It kind of makes a smoother resulting image. So, also, we would like to look at the image, and so the function for looking at an image is image_sc, and you give it the file or the variable as a parameter. And so we'll bring up a figure here that has the image shown to you. Okay, so here's our original image, and then we could use the imresize function that we just learned about to double the function, or double the image. Whoops. Okay, well that's a good learning thing. Okay, so if you're doing something on an image and you're setting it to a variable and you don't put a semicolon, then it will then print out the image's numbers to you, and you'll get that like stream down that looks like the matrix. Just remember to put semicolons because then it kind of messes up your history or your command window history. Or the output history rather, because you might want to go check something out that you did before, but too bad it's all overwritten by this stream of numbers. So watch out for that. If that does ever happen and you want to stop it, because if it's a huge image it might actually take a while to print everything out, then you can just press Control C. So if I was to do it and then press Control C, it stops immediately. Okay, so let's set that variable and then show the image. So it's actually looks the same size, but it's actually a bigger image. If you notice, this is the original, and it's 300 by 400 pixels, but this one is 300 or 600 by 800. But they still show the same because MATLAB just shows all figures in the same size by default, I guess. Okay, so that's image resizing. So now, if we wanted to make this image grayscale, then we use this function image to, or RGB to gray. And so here we see that it just takes the RGB image as input. Oh, so I've been using these figures and I haven't been explaining. So if I was to show image, let's see, the first image, the original, and then call it again with a different image, then it will paint that figure with the new image. But if you want to do it on a whole nother figure, figures are like these boxes here. So if I was to make a new figure and the argument to the figure is just an identifier of it, so you just give it a number. So this creates a blank figure. If you once you call a figure, then the current figure handler is the one you just made. So if I was to call figure 5 and then type image sc, then it will use the figure 5 instead. And so now you see we have both here. This is not grayscale because I think I didn't do the image map. Okay, so that was a little break there. I had to stop the video. So I think the last time when I left, we were right here, and it shows the grayscale image, but it's not in the correct coloring. So there's this function called color map, and you give it a parameter gray, and it will just take the current figure and change the color map to grayscale. Okay, so now another function that's useful is imRotate. And so image rotate takes an image and an angle, and the angles are in degrees, and it says here the direction is counterclockwise around its center point. So if we were to make a rotated image of the grayscale image, and we wanted to do 37 degrees, we would do that, or maybe not. Oh, I typed the wrong thing. Okay, that should do it. Yeah, so there's the rotation. So to get statistics, you can flatten the matrix like we did before, and then use whatever function you want to compute the statistics. So there's a mean function. So if you take the mean of 1, 5, and 4, then it will give you the mean. So what you can do is take g and flatten it, and then get the mean. So the mean value is 87, or you could do things like standard deviation, which isn't a thing apparently. Sometimes that works. Guessing that is. Okay, just STD. Okay, and if you use a standard deviation, you have to convert it to a double first. There we go. Another thing that's useful is randomly generating stuff from a Gaussian. And so there's a function called normal random, which will take a mean and a sigma, or a mean and a standard deviation, and then the dimensions of the data that you want to create. So let's say we wanted a matrix of, just make sure I'm typing this right. Okay, a matrix of values that are pulled from a Gaussian with mean 0 and standard deviation 1. And we want the size 3 by 3. Then we would just do that right there, and it will create the matrix. And then the last thing we are going to show is how to create a function. So if you just go over here and you create a function, you just do new file and then function, and you name it. So let's make this function let's just make a function that takes a file as input, an image file as input, and just shows it. So if we double click on this, it'll open up the editor. And so you can create the output, which in this case in our function will be nothing. You can actually do, I guess actually I'll change the function to something that does have outputs, because that would be more useful. Yeah. Compute mean of 3 numbers. And we have values A, B, and C. And so we could just, what you do is you name the variable that you want to be outputted, and then you calculate it in here. And so you can actually do multiple outputs. So you could have another variable, let's say u, that is, I don't know, I'm just making this up, b plus c. And then what happens is whatever these variables are at the end of the function, they'll get assigned that. So now we could, so you have to have the same name as the function as the file name. That's kind of a, it's because of the way MATLAB looks up functions, is they look for the file. So we'd have to change this to the name of the function. And so if we'd had variables x and y equals compute mean of 3, 1, 2, and 3, we have x is the mean, and then y is this plus this. And then the last thing to show is one little tidbit. So let's say I did all that and then I wanted to come back to it. I gotta wait for this. Okay, so let's say we now wanted to do that same function. It's going to give us an error because it doesn't know where that function is. And so what we have to do is add that file to the list of files that MATLAB is looking at. So if I go to the folder, then it'll already be there. If you're not in the folder, what you can do, or if the function is not in the folder, then you can go to the function and right-click, and then there is a Oh, I guess it won't show up right now, but if I go back, it should. Yeah, okay. So even though it shows compute mean of 3 right here, we won't be able to use it because because we're not in the folder. Now, if we right click and then do why is this not? Oh, alright. You have to use the whole folders. So you there's this thing called add to path, and you just add that folder to the path, and then now you can use the function. So if you can't ever, if you have the problem of MATLAB not being able to find your functions, it's probably because the function is not on the path. Okay, that pretty much sums it up. Alright.